Hey physics students, it's Mr. Galoya coming at you again. This is the first video of several I'd like to put together about our current unit called projectile motion. So projectile motion is an example of a two-dimensional motion. So we have motion along two axes simultaneously. We could go along the x and the y-axis. We form these sorts of parabolic shapes called trajectories. This was another research interest of Galileo. We're going to be using then our kinematic equations, our how fast, how far combination timeless equation, look at things such as height of the parabola or the projectile, how much time it'll be in the air, how fast it's moving at different positions, how far then maybe the projectile travels forward. Just like really with the unit on free fall, we see kind of a clash of ideas, the old ideas of Aristotle and the newer ideas of the Renaissance and Galileo. So Aristotle had studied projectiles, and his explanation really of a projectile was that the object would be pushed along this trajectory. This force was transmitted through the air. It was called the impetus. It was believed then that the projectile would travel in this trajectory until the impetus was used up, and then it would fall straight down. Here's kind of a picture showing Aristotle's view of what a projectile did. Traveled forward or upward and forward under this impetus. When that impetus was used up, it would fall straight down. That view then was held for a long time, through the Middle Ages and really up to the beginning of the Renaissance. Here's kind of another picture of Aristotle's ideas here. See the projectile, it just falls straight down. With the development really of cannons, we see kind of an increased interest to really understand these trajectories and the paths at cannonballs and other projectiles travel. And Galileo then kind of studied then this idea of projectile motion, and became, like I said, important to understand these trajectories. Galileo then and others realized that these projectiles really were not traveling in the sort of method that Aristotle proposed. Instead, then, these projectiles traveled in smooth, curved paths. But understanding the type of path was not easy. Now, we know Galileo, from what we studied in free fall and ramp motion, that Galileo used the inclined plane to really determine how objects moved down ramps. And he found that objects got faster and faster. We have uniform or constant acceleration for something like a ball going down the ramp. Well, he used the same sort of apparatus, the ramp, to kind of help him with projectiles too. And this is kind of what he did here. He basically put this ramp on a table, and he then allowed these balls to fly off the table, and these balls then were kind of inked, or it allowed him to find and to measure their locations when they hit then the floor, the surface. And by manipulating where the ball started, he was able then to come up with different positions, etc., and measuring this kind of curvature, this path that was obtained by the balls that went through the air. So where the balls then hit the floor, they left then these marks, and Galileo could measure then the horizontal and vertical distances and then the speeds that the balls moved. He was able then to determine then that the balls then traveled in parabolic sorts of arcs or curves. Here's some of the pictures here from what we see Galileo doing. You can see maybe the inclined plane here, and then some of the measurements that he would make depending on where the ball was initially placed on the inclined plane. So in this first video, what exactly do we want to do? Or what do we really want to talk about? I want to discuss the generalized nature of the projectile. We have two really types of motion that we see with the projectile. We have the forward motion, the horizontal, and then we have the vertical motion. We're going to find out that this forward motion is our constant velocity, CV. CV motion horizontally or forward. But once the object is in the air, then it's going to be in free fall vertically. So we're going to have then an accelerative motion vertically. So both of these sorts of ideas then or motions are kind of merged together in what we see as what we say is the trajectory. I like to break trajectories up into three types. So this type, for example, we saw off this table, I call then a type 1 trajectory. We start then with an object moving horizontally, and we see then kind of this half parabola. I call that then type 1 trajectory. I call type 2 trajectories then are full parabolas. So an object might start at the ground and be projected at some sort of an angle, and then it would end at the ground. We get a full parabola. So for example, maybe someone's kicking a soccer ball. It starts in the ground and then comes back down to the ground. Finally, then we have our type 3 trajectories, what I call type 3, and those are our asymmetric trajectories. So our starting, our ending heights are not the same. We get these kind of partial sorts of parabolas. Now, to show then these two types of motion, horizontal constant velocity and vertical freefall motion, I'll then complete a Logger Pro video analysis, and I'll do that within the video also. Again, I've created this video for my high school physics courses, and there's kind of a handout that I also have while I go through then the notes.